Hello, everybody. Welcome back to Top Tech Culture. So, on today's episode, I'm excited to show you guys something really cool. We're building a text to speech application from scratch using Google Text to Speech and Google Colab. And the best part is, you don't have to install anything on your computer. This is zero setup, guys. So, all you have to do is open your browser and we start the build. But if you're a beginner or you double with Python, not to worry, we'll be doing this step by step. So don't forget to hit the subscribe button, click on the notification bell so that you're notified whenever we upload. Let's get started. So for our text-to-speech build today, we're first going to navigate to Google Colab Research. As you can see on my screen, I have collab.research.google.com. Now, in order to have access to Colab, all you need is a Google account. So with this, you can navigate to this and then you have this screen. So we're going to click on code. We're going to start a new file. So first of all, we're going to say new notebook. We're going to navigate to a new notebook. That's where we're going to be doing our build here. It opens beautifully. You can change the name. Let's just change this name to, so we're just going to change the name to text to speech, how you want it, and then we'll start coding. So our first thing we'll do is do installation. So we'll first start with the installing the Python, the PDF reader, because for our text-to-speech application, we're going to be reading a PDF file or a text file and then convert it into audio or speech. So on Colab, in order to install, you bring this exclamation mark to install. Click the same way we install Python libraries. It's the same here. So I'm installing the Google Translate TTS. This is a library from Google which allows us to do text-to-speech translation without needing to, access API calls. So after that, I'm just going to, you can click on this or do Control Enter in order to start the installation. So as you can see, it's installing it. Some of them I've already installed, so you can see requirements already satisfied. And then it's done. It installed the gTTS, successfully installed. So the next is that we're going to be importing our libraries, which we'll be using. So the OS, import OS from path library, import path. So you see there's even IntelliSense here. Yes, it's Google's IDE that we can use. So PDF, yes, from gTTS, we import GT. Okay, thank you. Lang. Yeah, you can see this lang. We didn't install it, which means it's a pre-installed already for us. And also time is also pre-installed. And then we're just going to do Shift Enter or just click on this. So it's done. The Shift Enter allows us to see the next. Have another one. Or you can just hover on any of this if you want code, if you want text. Text is to add comments and stuff like that. Code is to insert a code. So that's basically what it does. So now we're going to be writing functions which allow us to extract the text from our PDF or our text file. And then we write a function which allows us to read the file. And then we clean the text and then we split the text. So as you know, in order to, when we're doing these type of, we're doing conversion rate, we need to convert the text in a format that is readable for the audio. Okay, so the first thing we're going to be doing is write a function to extract the text from the PDF file or the text file. So we're going to call this extract text from PDF. This is the name we're giving it, and we're going to pass the path to the PDF file. So first we're going to be doing a try except in order to catch any errors. Very, very important for error handling. And then with open PDF path, oh, the intelligence is not being nice to me now. PDF path. We're reading the file as a file. That our type is that whatever we're opening is. Let me close this try so that our intelligence will work for us. So except, every try goes with an exception, except as E. So after that, we're going to print error reading PDF. And then we simply pass the error message here. And then we return none. All right. So this is done. Not to worry about this red line. It's simply because I've opened this and I'm seeing that there should be something under it, but an except is here. So here we're going to define a PDF reader. And we'd say that we call this PyPDF2 library .pdf reader. Oh no, this is not PDF reader. And then we pass the file here. This is where we're creating the PDF reader object here. So first here we open the PDF in binary mode, and then we're creating a PDF reader object. And it's always good to, console log every stage that you're at, just for error tracing. So here I'm going to define the text as an empty string, and I'm going to print so that I know that I'm done creating the PDF reader object. And then it should simply log this to the console. Processing the length PDF. Come on, give me good intelligence. The pages. And then I'm going to pass pages. Okay, so now this is done. So here we're going to say for our page num page, which is inside. So we're going to loop through this PDF reader pages that we created, this object we created here. We're going to go through it, enumerate through it, and then extract the page num and then the page. So PDF reader dot pages. And then we're starting from page 1. So this loop, what am I missing? Oh, my bad. Okay, this is an underscore. Indentation is very important in Python, else you're going to have lots of errors. It doesn't use the semicolon that we use mostly in JavaScript in Java, but for Python, its termination is, or ability to understand and read each sentence line is indentation in Python. So extracting page, we pass the page num, we divide it, the length, the PDF reader dot pages. So simply all that we're doing is that we're opening a PDF file and we're looping through each page to extract the text from each page, and then after that we'll just combine all the pages into one big text string and return the complete text. Okay, very, very important. This is how we can then convert it into audio. So after doing this, we're printing this. The print statement is just to know what stage we're at each step. You can skip all these print statements if you want to. So page.extract text. So we're extracting text from the current page, and then we're saying if the page text, if this is true, then our text, we're simply going to concatenate what is in our text is equal to page text plus a next line string. Okay, we're just adding page to the next. We're just adding page text to the total of the text that we already have. And this is just to let, when it's reading as we go, is let to it know that we're in the next, we're printing out the next line. That is the next line of text. So it doesn't put them all together just for sentence interpretation. Okay. And after we're done with this, we're going to return. Our return should, this indentation is very, very important, guys. Okay. Any missed indentation I do here, we just throw everything off board. So I'm going to return the text dot strip. We're removing all white spaces. When I do this text dot strip, it simply means I'm removing all white spaces, and then I'm returning the text without the white spaces. So this function, extract text from PDF, is done. So when you're done, you just Control Enter. No, my bad, Shift Enter. So you can get the next. You can put all of them together in one, text here, but just for readability, I'm separating them. So the next thing we're going to be doing is we're going to open the text file. This is for a PDF. So this is when a user passes a PDF. And then we're going to have a function which allows the user who passes a text file. So we're going to open the text file, read all the contents in text into something much simpler. This is much simpler than the PDF because the text files are already in text format. But then you have to give options to your users, application users. That's why we have the PDF function. And then we're just going to go into the text function. So def read text file, text path. Then we're going to do our try like we did before. Try except, exception. There's too much space. Exception as e print error reading. There was an error reading the text file. We pass the error message and we return none. So in our try, we open the text file. So we text the path. And what do we pass? The R encoding. And then we need to pass an encoding, a UTF encoder. UTF. Then we read as file. Not to worry, I saw this. Okay. And then when we read this file, what do we do? When we open the file, what do? We read the file. So read, and then we simply remove all kinds of white spaces. So we read the entire file, and then we remove the white spaces. It's very simple. This is a little bit, this involves more steps because we're dealing with a PDF reader. but this is simply a text file. So this is easier. Let me just write this, change this. So now this function is done. We move to the next, is that we're going to clean the text. Very, very important in any machine learning application. You need to clean your text. This is very key because whatever you feed, we're not dealing with foundational models. We're dealing with a library that works with Google Translate. But we're going through similar steps whereby when we're cleaning data before we feed it to a particular library or a particular model, because the data, a very clean data is very important. It's fundamental to having clean output. This is very key in any application design which involves handling data. So the next is that we're going to remove extra white spaces like multiple spaces, tabs, new lines, and all that, special characters that might break the text-to-speech translation library. So we make the text cleaner for speech conversion. Very, very important. So when to define a function to do this cleaning, we'll call it clean text. Clean text, and then we're going to pass the text that we obtained. And what are we going to do? We call it text is equal to join. Then the text that splits. So we're moving extra spaces, new lines, and tabs with this single line of code. And then we say text is equal to text that we split and cleaned, replace with this. So we're removing null characters. This is representing removing null. Next function is called the split text smart. And why split? Simply the Google TTS has a limit of 5,000 characters per every request, because we'll get to that library and you know it, you'll see it, that we're using the Google TTS. This particular Google text-to-speech library has a limit of 5,000 characters per each request. So long documents need to be broken down into small chunks. And then how do we do it? We first try to split them by sentences. So how do we get a sentence? We use punctuations. We use stop characters like full stop, exclamation, question mark to indicate sentences. And if a sentence is still too long, we split it by words. So we keep adding sentences to the chunk until it is almost full, and then starts a new chunk. Okay, so it's very, very important. That's what I'm explaining this particular function before we start. So we call it the split text smart. We're trying to make it smart. And then our text, we pass our text here, and then our maximum characters. We're going by the Google. The maximum is 5,000, but we're giving our maximum to 4,500. Yeah, the limit is 5,000. I'm choosing to use 4,500. So the length, I'm going to find out what is my length less than, if my text length is less than or equal to my max characters, I can proceed to continue. So if it's less than or equal to my max characters, I simply return my text. There's no need to split it or chunk it or do anything. We pass it to an array. So we're just trying to say that a text is too short for it to be, chunked up. There's no need to split it. But if it's long, if that is not the case, first of all, we're going to define chunks. An empty string. This is to store the text chunks that we're going to do. Current chunk. Here we're saying that the current chunk being built, we're defining an empty string for our current chunk. And here I need to import a library called the RE, which I should have imported here. So just for cleaning purposes, I'm going to import it here and run this particular one again so that it recognizes it, that it is going to be used. Yeah, sometimes along the line you forget to import certain libraries and then you have to do that. You can import it. I could have simply imported it here by doing import RE. Yeah, but it's not necessary. I want a clean build, so I'm just going to import it at where we're all importing, just for, you know, grouping stuff and making the build cleaner. So RE the split, I'm going to split the sentences at periods, exclamation marks, question marks, and all that. So we're going to split. RE is simply regular expression. Okay. So here we're going to have the question mark. This is simply dealing with regular expressions. This is a whole new world of its own. I need to be very careful. Okay, S plus. This is how I'm splitting it. Question mark. Okay. So now I split it into sentences. So now I'm going to be looping through this sentences. Very, very important. So I'll say for sentence, in sentences, if the length of the sentence, very, very important. This control is very important. So for each sentence, if the length of the sentence is greater than the max characters, which means we're going beyond, we need to split it. Okay, so we're going to say words is equal to sentence dot split. And when we split it, we store it in a temporary chunk. We will delete all these temporary chunks, not to worry. We create a variable called empty temporary chunk, and then for the word in words, there's a better way to optimize this code, guys, but I just want it to be as simple as possible. So for word in words, if the length of the temporary chunk plus the length of the word plus 1, this is less than or equal to the max characters, it means we can store it. We simply store it in the temporary chunk. Word plus, give it an empty space. Else, what do we do? Else, if our temporary if our temporary chunk is true, it means that we have data there. We append our temporary chunk dot strip. This is just dealing with the sentences, okay, guys? After that, we simply store in our temporary chunk is equal to word plus empty string. Now this is for it. So after going through the words, we say that, and then checking if the sentence is greater than the max characters. We're done splitting. Now we need to have another if where we're going to check the length of the current chunk. So the length of the current chunk, oh, I keep forgetting this is not needed. I'm not in JavaScript. Oh, Java environment. Okay, so length sentence plus 1. If this is less than or equal to the max characters, we can just return it. What do? We say the current chunk is, we simply add it to the current chunk. We don't have to split it again. Sentence plus empty. Else, if this is not true, we need to, do the whole chunk splitting again. Else, if our current chunk is true, chunks dot append current chunk dot strip, and then we simply assign our current chunk equal to sentence plus empty. All right. Yeah, if else is a lot. So after coming out of the sentences, after looping through all the sentences, we just simply say, if our current chunk is true. After all of this, we simply do chunks dot append our current chunk dot strip, and then we return the chunks, because this is why this function was initiated in the first place. So we return our chunks. We run this to ensure that we didn't have any errors. Let's say I remove this. Let me just comment this. Let me just undo. Let me just comment. Let's say I don't add. Let's see. It still runs, but when we're using this particular function, we're going to have errors. Okay. Or let's say I comment also on this one. I want to show you how the error works here. So here you can see that this is missing. It says incomplete input. It throws an error. So it's not always marking it correct. It means that when you see something, the green lines here, it simply means there were no errors found. So with this, you can clearly see there was an error found. So I just need to undo this and then undo this and run my file again. So it's clean now. So the next thing is that we're going to take multiple audio files. So now we're going to be combining the audio files, because remember we've divided all the sentences and all that into chunks, and it's going to be converted into audio. So when it's converted into audio, we need a function that brings all of them together. So when we're listening to the audio, it doesn't seem like it's just mentioning words. It's forming sentences. So we also need to, put everything together that we split in audio to produce an audio for us. So I'm going to define a function, and what this function is doing is that it takes multiple audio files, like the temporary chunks that we're building here. It's going to take them, loads all of them into one, loads each one, combines them into one long audio file, and then it saves the final result. Why is this needed? It's because the text is split into chunks, okay? So we're going to be getting multiple audio files. What I'm doing here, simply because we have a maximum, characters that the Google TTS, Google Text-to-Speech Library can hold. So based on its maximum characters for request, we're going to be generating multiple audio files because our text can be very, very long. So after doing all that, we need to bring all of them back together in order to form a complete audio file that is like reading the entire text file or entire PDF. So our function is, we're going to call it define combine audio files. I need to give my definition better. Audio. And here we're going to take audio files and then the output path. and passing the output path to it. So we have our try, like we did before, except we're going to have two exceptions here. But for now, let's do the exception that we know, except exception as E. And then we're going to print our error. Let me leave this here so I don't jump into it. Let's finish with a try and then we can, because we'll have two exceptions here. I don't want to jump the gun. So from PY DUB, this is an import because we need a particular audio segment. So I'm going to go up to my imports and then I'm going to do this here. So from this particular library, PYDUB library, as you can see, it's already installed on Colab audio segment. We run this again, and then we come and use it here. So from this, we're going to define combined is equal to, we call audio segment dot empty, initializing this. And then we say for audio file in audio files, the looping, we define segment is equal to audio segment dot from MP3 audio file. So we're passing this to this particular audio segment library, and as you hover, you can see what it means. It simply says it's an object representing segments of audio that can be manipulated using Python code. So if you don't understand any of the code, just hover on it, and it has IntelliSense in Google Colab, which allows you to do this. Okay, so after that we have combined. We simply call the combined and we're putting everything together. Segment. Simple. After that, being done with this, we say combined dot export. We export this output path, and our format is MP3. You can use the format that we're using for this particular bit. We're using MP3. And when you're done, you simply print so you know where you're at. Simply print and say, let me copy this particular emoji. I like it. Simply say combined the length of the audio files, audio segments. So this is done, and when this is done, we need an exception error, which is an input error. What do I mean by an input error? We're outputting to ensure that our audio files there was no problem. If there was a problem during this whole audio imputation, conversion, and everything, we need to catch an exception for that particular one, and we call it the input error exception. And when this error is caught, it's a special type of error for catching input problems. So we have a warning, simply that our library for handling all of this was not installed if there's a problem. And then we saving first, chunk only. Then we can also print to, tell the user what to do. We're telling install, pip install. We're telling it what to do, a solution to the problem. It means that when you hit this particular error, it simply means that a library is missing. That library is missing. So please follow suit and do this. And we'll say also install FF MEG, and this is simply a system requirement for PYDUB. Simply because Colab provides us with all of this, so I didn't have to install it. But if you're doing it from your IDE and you don't have this already installed, you have to install it. Okay, so now if the audio files, so now after going through all this, in your exception, import exception now, if audio files is true, we need to import something. If audio files was true and you still got this error, your audio files is true, you simply do something here. I'm going to import this. Import to, yes, this already exists. And we'll use this dot copy audio files and then the output path. Then we print. Simply we're saying, let me just do copy paste so we can move faster from my old build. Save first chunk only out of the length of this, if this is true. So now this exception, you can understand why we have two exceptions. So the next exception is simply that, there's an error combining, we'll simply print to the user that if you hit this exception, the general exception, it's simply because there was an error combining the audio files, and then we simply print saying that falling back to the first chunk only, and then we go back and simply say going to have this whole if audio file thing again. So if audio file, we copy, we don't need this particular output because we already output it. We simply copy the audio file output path, and then we are done with this. This is not returning anything. It's simply exporting to an output path, which we're going to be using. So we run this, and this code ran without problems. Now we're going to hit to the main function. And this function, we're simply breaking it down. What does it do? I'm going to copy and paste this function and then explain it step by step, because it's a very long function and we want our build to be as fast as possible, guys. So please bear with me. So I'm just going to copy and paste. This is our main function, guys. This is the one that is going to be converting our PDF to audio or our text to audio and whatnot. Now, this function, I'm going to break it down section by section. What does it do? It simply takes your input file. It checks if the file exists within your folder, and then it creates an output file name. So if you have like document.pdf, document.text, it simply converts it into document.mp3. So let's read it step by step. Now this function takes an input file. It has the output. Initially it's none. And then the language, here you can specify the language that you want it to read your output file into, or the accent and all that, and how you want it to read. Slow is that false. You don't want it to, And then you have the accent.com. So first we're converting. You see I have all these, how do you call it? All these comments here just to let you know what we're doing. So we're simply reading the comments, but we're explaining it. Now read text to file. This is complaining why read text to file is not defined. It means that we're missing a function. Read text to file. I am missing a function for sure. I do have, oh, okay. It's the way I defined it. Okay. So now we're not having any problems in our read text to file. Where are you at? Okay. So simply put, we check if the file exists. that is here, we have here. And then what are we doing here? Input part exists. So first of all, we have what we're accepting in this function, and then the path, we're converting the path to an object using this particular path library. And if the file exists, this is simply to check if the input path exists. If it exists, the file was not found. Let me remove all these comments so that we can understand, because I added these comments to help me understand what I was building in order to see where my errors were. I'm just going to remove all of them and then explain to you guys so it doesn't distract you guys. So here I'm simply checking if the file exists, and if the file does not exist, it simply throws an error, file not found, and it returns none. Error control, very, very important, guys. Now the next one is that what is it doing? It's an auto generation. We're going to be auto generating an output file name if it is not provided. So we're simply saying that we're auto generating an output file name if it's not generated. So here we're saying if the output file is none, that is if it does not exist, then we have the input path where then we append the suffix of MP3 because we're using MP3. This is simply a name extension, guys. Or else, what do? We convert it into a path. And then we continue. If this is found, then this will execute for us. Very, very important. So you realize that we're catching all kinds of errors here. Very, very key. And then we have our file extension. What is the next one? We're trying to extract text. What does it do? It looks into the file extension. If it's PDF or if it's text, it calls the appropriate function, and then it gets all the text and determines the file type and extracts the text. So here we're saying that if it's PDF, do this. If it's text, do this. So if it's PDF, we simply print, we detected a PDF file, and then we call the extract text from PDF function, which we defined at the top here, extract text from PDF. So they're all coming together, and then we pass this. This is for PDF extraction, as the comment says. And if the file extension is a text, we simply say we detected a text file, and then we call the read text file function as we pass. This read text file function is here, guys. We defined it here, and this is here. Else, we simply say that the file type is not supported, and then we return none because we're dealing with only 2 file types. So you can create as many functions as possible to handle the various file types that you want to deal with. Now we're simply saying, now when we get here, we're saying converting the text to speech. Now here, this is where the magic actually happens. This is where we're going to be calling the Google Translate text-to-speech library object. We're going to call this particular object. And then what does it do? It takes our text, sends it to Google Translate service, and then it returns to us an MP3 audio file and saves it. This is very simple. This is not using any APIs because the gTTS library handles everything behind the scenes for us. So this is what we used to do before the emergence of generative AI. We're going to have another video for us to see implementing the generative AI version of this particular text-to-speech application so we can see the differences and we'll see the advantages of using the generative AI compared to using this particular library. But for this particular build, we're focusing on the gTTS, the Google Text-to-Speech Translation Library. This is what we're doing here. So here we're converting text to speech and we're cleaning the text. Very important. If you remember this particular helper function, we clean the text here. Very simple function, simply removing null values and all that. We're cleaning the text. Where are we? We're here. And then we split it into chunks if needed. You remember, split text smart into chunks, and then we simply print I wanted to see how the chunks look like. So I just printed we're outside. That is we're outside the text smart, and simply to see the chunks if they exist. Okay. So now if the length of my chunks is greater than 1, we split them. We simply say text splitting into chunks. Then we have the audio segment. We're simply storing it into temporary audio files, and we'll eventually delete them, as you can see. Now for here, we're saying that we're enumerating, we're looping through the chunks. And if our chunks is greater than 1, we call this processing chunk again. And then we try. So this is where we're creating our gTTS object with the text chunk. So what does this do? This is a text to speech. This is the language that we're asking it to, give the audio in. Slow. So this is, if it's true, it should be, the speech should be slow. We don't want that. So remember that we pass false here, that we don't want our speech to be slow. And then the accent, this is US. Here we're dealing with accents, could be, is equal to US or UK, British, the accents that we wanted to use. Anyway, now for each chunk, here we're simply saying that the length of the chunk is greater than 1. So the multiple chunks, we're saving them into a temporary file. As you can see here, TTS, this particular object that was generated, we're using it to save the temporary file. Then we're going to append them into this audio segment, this array that was built here, that was created here. We are appending the temporary file. The single chunk, we save directly to its output, tts.save. And then we need a time to delay to avoid rating the limit. So why the delay? As I wrote here, Google might block you if you have too many requests fast. This is simply to avoid bots from, generating audio, text, and stuff like that. So we're including a time here, sleep time, so that we'll not be sending too many requests at a time. Yeah, to avoid making our application seem like it's a bot. But this doesn't take anything away from application. It doesn't slow the application in any way or form. So we're just adding this. And then our exception, but you can test it. You can test without including the delay, and we'll see how it behaves. Okay. So now our exception here is that if there's an error here within this particular try, we simply say an error processing the chunk. So for our temporary file in audio segment, if the part, we simply check if the part exists, we remove the temporary file, and then we return none, because this went away. So we don't need any temporary file here. Again, we're cleaning it up. Now, if our length of chunks is greater than 1, we're here. We're combining audio segments. We simply call the combine audio segment if this exception was fine, if everything was fine. We're simply calling this combine audio files function. We're joining all the chunks together, and then we delete the temporary files because we no longer need it, because we're putting everything, we're combining all the audios together. So all the files that we created, the various chunks into audio files, we're deleting it because we don't need it again. So we're going through the audio segments, and then we're simply removing it from our folder. And then after that, we just want to calculate our file size, just so we know the size of our file. In case you don't have enough storage, you know what you're generating, and then you can put measures in place for that. We simply print this, and then we return our output. If there's a problem with this, we have an exception where we say there's an error doing the conversion. This is a general exception. We're troubleshooting. We need to check our internet to verify if the language code is correct. We try again. If there's a rate limiting, that is the part where we included our time. Where is this? Yes. And that is the function, the main function. So we're going to do something here. This particular thing I'm going to define here is just for Google Colab purposes. If you're building this in an IDE, a Python, a PyCharm, or Visual Studio IDE, the way you import your files will be different, okay? But this is simply for Colab purposes. So here we're just uploading our files and then reading it. So upload your file from Google. You run this application, and what does it do? This is simply asking us to choose a file. Simply put, I want to stop this. Yeah, I interrupted it because we want to run it from top to bottom, okay? And then after doing that, we call a function. This is the function that we're going to be calling. We're going to be calling this function, and we'll see everything beautifully done. This text here, when you're doing a full-blown application, you could put a variable here that you'll be passing from the front end that will come here, and then it will call this function with it. So for us, let me remove this, because the variable I'll pass here will be determined on the file that I would upload here. And Google Colab is going to store our file here. So let's start from the top, guys. Now that our build is done, let's run it from the top. We already installed this. This is checked. We already imported this. This is checked. Let's just do this whole thing again. This is fast, guys, so not to worry. We just go here. We run our various functions just to ensure that everything is fine. This is Shift Enter that I'm clicking on my application. So now we're here. So we're going to upload a file. So I need to choose a file. Okay. So you can see it. What did it do? It's showing the file here, last modified. It saved the file, blah, blah, blah. It's been uploaded. And it took some time before the file was registered here, as you can see. So now Google Colab has this file. So I'm simply going to copy the name and then pass it here. This is simply for Colab purposes. If you're doing this in an IDE, there's another. Let me know in the comment section below if you want us to have like a full functioning application with this, because there's a lot you can do with this particular application. So we're going to run this, and I'm simply saying that the language is in Italian, because the file that I uploaded, as you can see, was an Italian text. I'll upload an English text so that we can also hear the English version and change the language. And then you also get to know the accent, because the language here I pass is IT. So we also want to find out what type of accent will we get if we pass language IT, but the file is in English. So here we can see that MP3 has been converted at. Okay, so now let's play this and then listen to how it sounds.
Eopia Giza, Egitto, è la più antica e l'unica. Certamente. Ecco la descrizione delle 7 meraviglie del mondo antico in italiano. Formattata solo con paragrafi separati. La grande piramide di Cheope a Giza, Egitto, è la più antica e l'unica.
So that we can clearly hear it. So I'm going to upload an English file, and then we leave the language here in IT to hear. I realized something while I was testing this, is that the language here indicates the accent. So if I upload an English file and then I leave here at IT, the accent, it uses an Italian accent to read the English version. So if I change this to EN, it uses an English, okay, it uses an English accent to read the Italian one. So let me change this to EN. Okay, let me delete this one. This MP3 file, let's make it again. Let's generate this file again. Okay. It's taking some sweet time to generate the file. All right, it's done. Let's run this again. Okay. Let's see. Okay.
Certamente. Ecco la descrizione delle sette meraviglie del mondo antico in italiano. Formatata solo con paragrafi separati. La grande piramide di...
So we realize that it's using, if you listen carefully, it's reading an Italian text, but it's using an English accent. You get it. So now we're going to change this PDF. I'm going to upload an English one so we can see how it reads an English file, and then I'll change the language to Italian. So let's start with, first of all, let me just change this to an Italian, and then run this thing to upload an English file, and then we see how it behaves. Okay. All right. I need to select an English file, I think. I found one. All right. Okay, this is an English file. You just copy this. Here. Let's generate this into. As you can see, it's an English file, 7 Wonders of the World, blah, blah, blah. So you can see here, yeah, the temporary chunk. You remember the temporary MP3 was divided because this is in 2 parts. So one temporary chunk, after that we will delete it. You realize that you wouldn't see it again here. All right. Combining audio segments. So it's going through the combining audio segments. It's done. Excellent. Let me change this text, this, because we're not trying to run this. We're trying to run this. And then let's listen to it. Okay. We're using an Italian accent here to read an English.
The *** 7 Wonders of the Ancient World *** were a collection of the most remarkable man-made structures of classical antiquity.
So you realize that it's using an Italian accent to read something English. If I change this into English, yeah, let me delete what was made. Let me delete this MP3 file. I think we'll probably update it, but just to be on the safer side, let's just delete it so it's not existent, and let's ask it to generate it. So clearly here, Selling Exposures in 2 pages. So that's when it needs to call the combined audio chunk, blah, blah, blah. All right. It's taking a sweet time. So you can see the first chunk MP3 that it got. And then it will call the combined audio segment here, that function. All right. I expected it to delete this chunk, but anyway. So okay, it's the same name, so it's not, okay, it took some time. It did delete it, you see. Guess Colab is not as fast. My Colab is not as fast as I expected it. Okay, so now let's listen to this in English. This is English, so we're going to listen to this in English. And the accents would definitely be an English accent.
The *7 Wonders of the Ancient World were a collection of the most remarkable man-made structures of classical antiquity, compiled primarily by Hellenic.
So we had it right. Oh, let's bear in mind that this Google Translate text-to-speech has 60 languages. When I did my research, I don't know if there's more, but there's 60 languages that it supports. So you can, based on your language, I think you can play with it and know how it behaves. That's an incredible build, guys. And with this is a simplified version. Let me know in the comment section below if you want a full application with front end where we're not using Colab. We're actually building in Python ID so we can easily generate, write a function for an API URL and then make use of it in the front end and all those things, guys. Let me know in the comment section if you want something like this. This is a very simplified build of text-to-speech where you can use in your website if you want accessibility for people who can't see, but they can click on a button which lets them listen to what's on the website. Some browsers enable all this, but if you have maybe a specialized app that you want to implement such accessibility, this build can be useful to you. So for this one, I think the AI comes in if you want to go generative AI for text to speech is when you want to, customize your voice. You want it to sound, for instance, you can input in the chatbot that I want you to sound, sad when reading this particular, sections of a text and all that. That's the ability of generative AI. It has ability to, customize the voices better compared to just using this particular library, which does simple text to speech. Okay. So let me know in the comment section below if you want more information about this particular library. It's called the gTTS, the Google Translate Text to Speech Library, a very powerful library that you can use for your text to speech applications. Okay, guys. There. So don't forget to hit the subscribe button, click on the notification bell so that you're notified whenever we upload.